Right, we're going to approach figure 7 question 3a. The commands covered for this particular question would be in particular the whole commands, and we'll be doing a counter bore diameter 24 with 8 millimeters depth, and it will be drilled through at diameter 16. Right. The second part is actually a revision, nothing really new, of your sketch commands, and perhaps maybe the use of the tangent constraint for this line to the circle, the diameter 40. Okay, so I'll run through with you how I will approach this problem. I will draw out a base first, then after that I'll create the step that's over here, then I'll draw the backing followed by the extrusion of this boss. Right, then I'll create the holes last, and follow, okay, the radius as well when I create the first base. So the base is 90 millimeters in width and 75 millimeters in its depth. Okay, so I'm sorry, 90 millimeters in its length and 75 millimeters in its width. So that's the first thing I'm going to draw together with the, and then later on add a fillet radius of R20. Okay. From here, it shows that 50 CRS. What is this CRS? CRS, if you were to look at your notes, page 13, CRS stands for centers. So what they're saying is that it is 50 millimeters, right, apart, right? So therefore, it is 25 millimeters from the center. Okay, 25 millimeters from the center. Then, and it is plus another 20 millimeters here because of the radius, so it is 45 millimeters from the center to the outer edge. Multiplied by 2, you get 90. Okay, so this counterbore is shares the same center as the R20. Right, so that will make it really easy for us to place our points as we move our mouse towards the R20. The center of R20 will pop up, and then we will pop our point exactly on that spot. Okay, so 90 and 75, let's go. Figure 7, question 3a. Create a new part, right? Metric, standard, create. Then what I'll do is I'll create a new sketch, and the front view, I'm going to draw from here on this plane. I'm going to rotate it across. I'm going to draw out a rectangle. I'm going to centralize the rectangle. Horizontal constraint. And I'm going to drop the width. The width is 90 millimeters. The length is 70. Enter, and I'll finish it off. Okay, and then what I'll do is I will extrude, and the extrude height is, let's check with the drawing, extrude height is 20 millimeters, right? From here to here is 20 millimeters. So I'm going to do just that, 20 millimeters. Right, and then there is a radius 20 on the front corners. Right, it's here, here. Click OK. Then I'm going to draw the step. Right, this is the center point of everything, so what I can do is I can draw a rectangle. Then I could centralize the rectangle to this. Then I can ensure that this is collinear. This is another technique of drawing it. Okay, you can actually just draw 3 straight lines and it works just as well. Right, okay, the step height is 5 millimeters. The width is the length is 16, so it's 16 and 5. So I put here 5, and this is 16. Okay, and because I centralize it, even if you give a very large number, let's say 30, you will notice that the rectangle adjusts itself and centralizes itself centered to the part, right? Centered to the part. So this is 16. Okay, then what I'll do is I'll finish this sketch and I will extrude it, right? It's in the other direction, and I'm going to extrude to this back surface, and I'll click OK. Alright, next I'm going to draw this shape over here, the backing. and I'll include the radius 20 or diameter 40, right? I'll show you how that is done. And it stands at a height of 50 millimeters. It is centralized, okay? So I will create a sketch on the back plane. So what I'm going to do is, this is the front, right? This is the front, okay? And I'm going to rotate to the back, and I will create my sketch plane at the back, okay? Then what I'll do is I'll just draw a point so that it makes it easier. Then I will align the point vertically to this axis, right? And from this to the center of the point, what is that called? It's 50. Okay, it's 50, right? So here 50, right? Now that's one way to do it. If you find it too troublesome, you don't like this technique, sure. What you can do is you can do this as well. Let me delete that away. You can just straight away just draw a circle, right? And the diameter was 40. Let's dimension it. And notice how I drew it off center. I didn't really try and draw it at the center so that I can use my align tool, right? And I'll align it vertically to this, right? And from here to here, it's 50. Okay, this works just as well. And this ensures that the circle is fully constrained, right? Because it's turned black. Then I'll draw a line. The line comes up here. I just put it to any length, and then I use the constraint, the tangent constraint. I'll constrain it, okay? Then I can trim it away, or I can draw the other line, right? As this is not too complex, I didn't bother with the mirroring effect. If let's say there are a lot of features, I may consider drawing a vertical line somewhere here, a short one, and then what I'll do is I'll mirror my features over, but that's not necessary. So what I'm going to do is I'm going to trim it, right? I'm going to trim it, and this is how it is, okay? Now, I didn't draw a line at the bottom. Why? Because I have a projected geometry here, and it closes the loop. It closes the loop. So I can extrude now, right? I can extrude now. It's in the wrong direction. Extrude it this direction, and the width that I need to extrude is 20 millimeters. 20 millimeters, okay? 20 millimeters. Then what I'm going to do is I'm going to change this to 20, enter. Then the next thing I'm going to create is the protrusion, right? And it shares the same center as the top curve. So what I do is I move my mouse over to the top curve. The center, the dot appears. The center of the curve appears. I share the same center. And I'm going to hit it at 40 millimeters. Okay, snap to here. Now it is still blue because I've not given it a definite 40 millimeters, and there it is. Okay, I will extrude it by 20 millimeters. Okay, so there it goes. Then the next thing I want to create is the hole type. I'm going to do it properly now. Create a point, move my mouse to the edge here, the center point appears, snap here, and that's finished. And then what I'll do is I will use the hole command. Whoa, this is just too big, right? What's the hole diameter? Diameter 20. 20 millimeters. Right? And I click OK. Right, just to confirm that it is 20 millimeters. Yes, that's right. The next thing I'm going to do, the last thing that I'm going to do is the counterbore holes. Okay, the counterbore holes with that. Critical dimensions are 24, 16, and 8. 24, 16, and 8. So let's try and memorize them. What I'll do is I'll put a sketch out here, and then I draw a point. Move my mouse close to the circumference of the radius, and the center of the radius will pop out, right? So I just pop my point over there, move my mouse to the circumference, the curve, and the center will pop out, right? Then I have it over there. Okay, and I will create my holes. Now this time round, it is not just a true hole, it's a counterbore hole. So the true hole, the one at the bottom, is 60 millimeters in diameter. The top one is 24, and it goes in by 8 millimeters. Okay, and you click OK. Now, what is so fantastic about this counterball menu is it is just that with a click edit feature, you are able to edit all these features, dimension, the countable dimensions, and it will automatically update itself. If you were to draw it out and create, right, uh, it through extrude cuts, you will need to go to the individual extrusion, and you may, with if your part is really complex and if it has many of these extrusion 2, 3, 4, 5, 6, it will be quite hard to identify where is the hole, which is the hole. And then when you change it, after you change the diameter of this, you need to open up another extrusion to edit feature to change this, and you need to open up another extrusion feature to change this. But if you have the whole command, all you have to do is edit the whole feature, and you are able to tweak these three dimensions in one go, in one opening, in one setting. So that makes it really advantageous. You may not appreciate it right now. You may think it's a hassle going through all the dots and points, but in the future, when you are designing more complex parts with a lot more holes, the whole feature would be a blessing. Okay, so with this, I click OK, and this is done, right? I need to save my file, save as, and this is figure 7 question 3a, figure 7 question 3a. All right, we're done. Thanks for listening and watching this video. Click the like button and subscribe, please.